Hey, what's up guys? Back again for another day of optimal start mathematics, mechanical engineering theory. Like I've said every video, read the paper. Inside the paper directory, all of this is based off of a research done by Pacific Northwest National Labs, and we're just studying it in Python little by little with the help of our AI generated lesson plans. So yeah, it's going really good. I'm learning a ton. Hope you guys are too. So here we are back again on the bonus days for doing some of the matrix mathematics by hand, because this was running in Model 3, which is in here, which we've talked about before. So we were using some math libraries in Python that kind of hide a lot of what goes on behind the scenes. But when we do a Java version of it in the Niagara 4 building automation system, in a block that I've showed you on previous videos, like we don't have any math libraries to help us out. So I'm attempting to code all this manually in Java with the help of AI, and then studying it and then looking at the effects. So if we get into our lesson plan for today, see if we can knock it out here. So here we go. Matrix multiplication. I'm sure people with like a computer science degree, they would have a whole college semester just geared towards this, but we're just kind of getting a crash course. So yeah, let's get into it. So matrix multiplication is defined as row times column equals a single value. The output entry is a dot product, which we've talked about before. Model 3 requires X transpose X, X transpose Y. Both are matrix multiplications. So why this matters: you can multiply matrices, you can implement regression in any language. Let's copy our code, and then we'll get into the micro exercises, which we do on a daily basis. So this is our code from yesterday. Maybe I'll just put this, it's almost kind of tempting just to comment that out. I'll just do Python math lesson, and here we go. So this is actually computing matrix multiplication, which I think we did. Yesterday we were just transposing the arrays. So yeah, let's take a look at this, kind of let it soak all in. We had our lessons plan. Our earlier lessons plans were going through just slicing the array, and then we can kind of multiply some values back and forth. So this is it is kind of doing like this. Kind of curious what this comes back in Python, because in Python we were talking about, unless you use the NumPy and put something in an array, like these aren't real arrays. These are just called a list in Python. It's simple data structure. An array is a little bit more complex, I think. So I was just kind of curious if what kind of data type this is, because it looks like an array, but I don't think it's a list. It's still a list. So then let's just play around here. Okay, so how is it doing that? I think it's, I'm just studying this, then it's adding these together. So I think it's multiplying this value times that value, and then this value times that value, then adding it all up to get a value of 17. Multiply a 2 by 3 matrix by a 3 by 1 matrix. So I think a 2 by 3 matrix. I have to like sometimes this takes me a little bit just to do some of this by hand. I just play around with this code right here. Apologize if it gets a little confusing. Maybe I'll just delete it. Okay, so this is our array. So I think I can even do in NumPy that'll give us a dot shape. So that's the shape of our array. So I think this is a 3 by 2 array, a 2 by 3, and a 3 by 1. So a 2 by 3, if we just put in some values, let's just say like this. By 3 and a 3 by 1 matrix, that would be maybe I'll just copy this and just call you Y. So 3 by 1 I think would be basically just one element in the array. Let's just put you like make up some numbers. Then I could just say y mp r equals mp array of our y. And we can do a print y and do the dot shape again. Kind of a neat feature from NumPy. Okay, 2 by 3 and a 3 by 1. Okay, so now when we multiply these together, just looking back on some of our notes, I think like we could just do, I'm kind of cheating with NumPy, but there's our previous lesson plan used some complex computer science pattern where it was actually slicing these arrays and getting the value. It's probably the real way to learn, but I don't have the time. So I'm just gonna do, so I'll just say, I don't know, product equals, I think it was just like these. NumPy had this at operator. Interesting. So, and it looks like it is a so the shape of the product array is 2 by 1. Which I guess makes sense. Gosh, I think that would be kind of a fun exercise of like how they came up with these numbers and debating if we have time to do that or not. It's always kind of tempting to try it just for learning purposes here. So I'm just gonna copy this. Paste it in. Use our computer science pattern right there. Ooh, and we get a little bit different result. So I think it's missing some operator, like to be able to, you know, do the math on a completely different row or column or something like that. But it would be really fun if I wanted to actually. I suppose we could even just ask our good old friend ChatGPT here. So, what is the equivalent? So so this operator NumPy produces a 2x1. Your loop computes only one number, and it even uses only the first two columns, not three. So I'm just gonna see, like, revise this to not use list iteration for learning purposes. And sometimes it's just a little easier to see what it looks like. It's the equivalent of NumPy only if you slice to the first two terms. Okay, yeah, so that's why we were missing some of the math. So let's try this out. Yeah, interesting. Okay, so that's how we got the first same two numbers. So this is suppose we could even just get rid of this altogether. And then we could just say this was y and this was x instead of a. Y. Oh boy, I screwed something up. Anyways, I don't think this is worth getting too deep into the weeds here, but it would be kind of like a fun way to I screwed it up again. Recopy it. So, you know, if we wanted to do our matrix multiplication by hand, this is what we're actually doing in Java in the program object, because that's all we have to deal with. That's all we have. We don't have our NumPy math computing libraries to make it all look easy, nice and clean. We actually have to do it manually in Java world. Another thing that I think is kind of interesting, at least in Python world, like the math I have heard like runs kind of slow in Python. And if you run things through NumPy, like NumPy is a compiled language, or NumPy was built in C or C++. So the math that it's crunching behind the scenes runs really fast compared to if you were just doing manual math like this. I've watched some YouTube videos on people doing machine learning algorithms from scratch, and when they're crunching lots of big numbers, that this manual math runs real slow in plain pure Python. But when you use NumPy, because of the speed of C and C++, like it's able to go considerably faster. But I thought this was kind of fun to be able to just if I really wanted to get good at this, I would probably have to spend a week at just playing around with this before it would really sink in, but as fast as it sinks in, I lose it. So I'm kind of glad we just have like a quick little refresher on what this is. And then what is our next question? What happens if dimensions do not match? Might be kind of interesting just to ask ChatGPT directly. I know they have to match in machine learning, or else the algorithm is not happy, it errors out. So what happens if dimensions do not match? Matrix multiplication only works if the number of columns in the left matrix equals the number of rows in the right, because we do columns times rows. If they don't match, multiplication is undefined, so that's why we get an error. So NumPy, if you did this in NumPy, how the shape is a 3 and a 1 2, the input operand 1 has a mismatch in its core dimension 0. I tried to match 3 with 1, but they don't line up, so that is why. Pure Python equivalent, why it breaks, your loop expects this, and if your length does not equal each other, yeah, you'd be computing the wrong math. So if the inner dimensions don't match, the dot product can't be computed, so matrix multiplication is undefined. Cool. Where does matrix multiplication appear in Model 3? So write a general matmul loop. Okay, I'm gonna ask ChatGPT just to crunch away on that while we look at some of the Java code. Okay, so in the vibe code repo, I'm just gonna go through the 1500 lines of Java, and there is like a method in here for fitting Model 1 or fitting Model 3. Let me just get here. Suppose I could have found this. So this is Model 1, Model 2, Model 3. This is predicting with Model 3. So when we just predict with Model 3, it's just math, just the coefficients for the math, pretty easy. That's how it prunes the history. So here we go. So Model 3 fit once, and it does it for heating and cooling. So there's different data for and we're in the summer, and different data if we're in the winter. Yeah, so this is it right here. So this is getting deep into transposing the data. So this is our delta t times weather factor. And then here we go. This is our raw calculations in Java. And it'll return our alpha D, alpha A, alpha B parameters. And this is our raw matrix math that it's done after a fit. So the way that the code works for models 1, 2, 3, and 4 is like they're only fit once after after we do an optimal start run, and so before that, we predict our minutes, and then we attempt to start the HVAC system before the building is occupied to condition the zone, and we capture the data of how many minutes it took to condition the zone, and so that's minutes, and then we also calculate our delta temperature from that. And then after we have a successful run, the building's occupied by that point in time, we fit the models once, and then they'll be fit again the next day. So they're only fit once per run, which would be typically once per day, because typically the buildings are only occupied once per day. So that is it. That is Java land for Model 3. If you want to look back on the paper for Model 3, what those coefficients were for alpha A, B, and D, feel free. So I'm curious to see what this was now for our last micro exercise for today. Write a general matmul loop. I don't even know what that is. But the key takeaway, matrix multiplication is structured dot products, which I think we got enough of that out of this video. I think I'll have to be using ChatGPT for some of these micro lessons as we get into Model 4, which is the first order physics. Totally different kind of math that, having these AI powered assistant is kind of nice. So here's a fully beginner friendly clear matrix multiplication loop. No shortcuts, no comprehension. So general matrix rule matmul. Oh, I think I've seen this before. It looks kind of familiar. Yeah, so it actually looks pretty familiar from what we've been doing with well, this is cool. I have a feeling if we could study a month just doing this math alone. So it's this matrix multiplier, like a routine in Python. It's exactly what we're doing in the Java code that we just showed in the program object. So this would be really cool. How it matches a NumPy, matches your Java 3 fitter. So yeah, it's pretty cool stuff, guys. So I'm learning a ton, and it's just sometimes a 50-day crash course is not quite enough, but is what it is. So I also want to mention, I'll probably be mentioning this a whole bunch, is like the next 50-day crash course I want to get into is data modeling, and doing this with a brick. So yeah, this is really exciting. I'm barely halfway through the math multiplication for optimal start, or the math, come on, words, like the math multiplication for optimal start. And like what I want to get into next is data models, graph theory, RDF, triplex, Sparkle queries. So this is coming. So yeah, this looks fun. So here we go. This is our next AI generated course, hoping to do this summer. So it's still winter here in upper Midwest USA, so this will be a summer and fall. I'm hoping to even do one in Linux. So powerful stuff. So thanks for watching, guys. Hope you have a great day.